Hello, my name's David Runciman, and this is Past, Present, Future, the History of Ideas podcast. Today, in our History of Revolutionary Ideas, we're going to be talking about a book that was published on the 24th of November, 1859, and has some claims to be the most important book ever published on any subject. It's Charles Darwin's On the Origin of Species, and the geneticist, science writer, and regular PPF contributor Adam Rutherford is going to help us understand why this is the biggest revolutionary idea of them all. It's a conversation in two parts. First up, what was the story of evolution before Darwin published his book, and how did Darwin arrive at his own revolutionary understanding? Adam, is it possible to say how close anyone got to Darwin before Darwin? Indeed, did anyone get close? There is obviously a long, deep history behind this story, and we're not going to be able to go into all of it. But we're going to be talking about how revolutionary an idea this was. And so part of that means we need to understand what went before. Did anyone get anywhere near?
I think it's important to make the sort of distinction between the recognition that adaptation had been described and has existed in scholarly analysis for thousands of years, that Darwin's contribution was actually to describe the mechanism. And that is where the revolution really lies in this discussion. And we'll come to why that's revolutionary in a bit, I'm sure. But it's a tricky question to answer. So you've got very ancient texts from the 4th century BC by people like Lucretius, who in his The Nature of Things, Res Naturae, describes an undirected process where the best adapted forms are basically sorted out through their adaptations to their local environments, and the ones that are not adapted are eliminated. Now that sounds like a pretty Darwinian description of natural selection. It's not bad at all. There isn't a mechanism involved in that. And it's quite, as often with these classical texts, the details are somewhere between confusing and not in great detail. Lucretius is not really, it's rediscovered or retranslated in the 13th, 14th century and becomes part of that sort of build-up to the Renaissance and Age of Enlightenment and scientific revolutions and all those terms that I'm semi-hostile towards. But it's Plato and Aristotle who really sort of set the first descriptions of classifications and of natural behavior of animals. And they both invoke a version of adaptation which is not naturally selected, which has an intelligent craftsman, so the demiurgos by Plato. They say that living beings are fashioned according to eternal archetypes or forms, and that sort of Platonic idealism. And Aristotle goes on and develops them. I think some people, and I've done this in the past, over-egg the essentialism that is buried in those ideas. And really, I think realistically, the essentialism which does dominate the period leading up to the Darwinian revolution in the modern period, in the early modern period, they are the ones that invoke essentialism much more than the classical philosophers.
And by essentialism, we mean the idea that each species is essentially itself in an unchanging way?
Well, that it has an essential quality. There is a version, a Platonic version of any animal, or indeed plant, and that there are deviations from that and there are variations upon that, but there is a quality of being a rabbit or a duck or a shark or a barnacle, and those things are unerring and they have been fashioned according to an archetype by a craftsman.
And we identify each of these things by identifying the features that make it itself.
Exactly. And so they recognize differences between organisms and they recognize that they are adapted for different environments, but not that they have emerged via a natural process or that there has been continuity in the emergence of those specific adaptations. And then there are various other sort of subtle descriptions or thin descriptions of adaptive processes over, well, jumping ahead 1,000 years now, especially in Middle Eastern And Arabic science, there's a couple of descriptions of somewhat adaptive processes. Also recognition of something that Galen, who is mostly remembered as being the great anatomist, the classical anatomist, although he never worked on humans, that there is comparative anatomy, which you see similarities in bone structure in very different organisms. And comparative anatomy goes on to be a significant player in the development of shared ancestry later. But I think in the telling of Darwin and the many, many myths of Darwin and evolutionary history, many people over the years have said, well, actually, someone else got this right earlier, or that Aristotle's version of adaptation prefigures Darwin or prefigures natural selection. And I just don't think those are very supportable positions. I think that we sometimes make the mistake of simplifying the pre-Darwinian models of how life is the way it is into a very modern and biblical creationist version, which is, the Noah's Ark story that all animals are created exactly as they are. Scholars and agriculturalists and people in general recognized difference, they recognize adaptation. I think it's fair to say there was an overarching design element to it, and the designer was a deity that changes over time.
And the evidence that they had to draw on, as you say, there's comparative anatomy, there is the natural world and the study of it. Later on, there are fossils. The things that had to be explained came to include increasing knowledge of the deep history through fossils of what had gone before in a way that wouldn't have been available to Plato or Aristotle or Lucretius, and did demand explanation. Before we get to Darwin, how much of a shift late 18th, early 19th century is there simply as the volume of available evidence grows?
Fossils are recognized in classical literature, but there's no concept of their age, and there's no real description of them being things that no longer exist. So in China, there's descriptions of what we now presume were fossilized dinosaur bones or other extinct animals, but they're just described as dragons. There's a key step which happens a little bit earlier than the 19th century, which is the Danish proto-geologist, who we refer to as Steno, Niels Stensen, late 17th century. He gets given a shark that has just died. And people are aware of stones which are sort of triangular sometimes with serrations on them. And when Steno does his anatomy of sharks, of this one particular shark, he sees that they are shark's teeth, but they're stones, right? So they're stones, they're not teeth. So how has this come about? And also they begin to find dinosaur bones in layers on cliff faces which are stratified. And so he begins the process of understanding that living things that are below the surface in these layers were once on the top. They were on the sea and they dried out and they have become living things. And so a key element in evolutionary theory is the age of the Earth. And, geology plays such a big role in the development of evolutionary theory. And a lot of it starts with Steno and this recognition that by this process by which living tissue, in a sort of atomistic way, the molecules of living tissue get replaced by the molecules of stone and the fossilization process occurs. That really begins in the 17th century. By the 19th century, there is this recognition that fossils are being discovered for animals that no longer exist. But the interesting question is, well, the fossilized remains they resemble living creatures as well. So why would there be things that are different but similar that have been dead for thousands of years? Well, I mean, we now know hundreds of thousands of years or millions of years, but why would the same types of organisms emerge in the same sorts of environments? And so that question begins, seeded in the early 19th century.
On the geology, how much of it does depend on people coming to understand this is a much, much longer story than human beings would traditionally have believed was possible? The idea that this might be millions and millions of years, that's a very recent understanding. And famously, even at the time that Darwin was doing this, there was a conventional view that you can tell the story of all of it in a few thousand years. It will turn out that you do need the long story for this to be possible at all. So how much of an understanding that this is a very long story is a precondition for this revolution?
It's absolutely fundamental. And I think to this day remains one of the biggest barriers to understanding natural selection. So until the late 18th century, the almost universally accepted truth is that the Earth is less than 10,000 years old. And so even with the establishment of variation and adaptive processes that are beginning to be discussed then, it all happens in a time period which is, similar to the biblical creation age of the universe that so many of the 17th century scholars really focused on. People like Newton and Ussher, and they're all landing on about 4,000 to 6,000 years old for the age of the Earth. It's the 18th century French scholar Buffon who really changes that story. And he's got ideas about the origin of the Earth, which are that the planets are broken off debris from the formation of the sun, which is not really that far from the real story, which is the debris, which is called the extrasolar disk, are bits floating around the sun after the early formation, and they clump together via this process of accretion, and that's what forms the planet. So Buffon comes up with the sort of idea of that in the 18th century. But he postulates that the Earth must be at least 75,000 years ago. So, 10 times longer than anyone is considering at that time. I suppose there's two things we might need to separate in this whole narrative, which is the origin of life itself, which everyone is concerned with, and the radiation, or how to explain the diversity of life. And they're slightly different things. But most people of this time are thinking about both things in parallel. Buffon really is, I think he's the most significant pre-Darwinian scholar in developing the ideas. He dies in 1788. His base was the palace, the Jardin du Roi, which is a big part of your revolutionary story. I mean, the French revolutionaries are all there, and there's a lot of scientists involved, right?
Turns out everything passes through the French Revolution. So Darwin himself, as a young man, before he went on the voyage we're about to talk about, on the Beagle to the Galapagos Island, which changed the world. Do we know what he thought, what he believed? So, for instance, on the question of the age of the Earth, this was a fundamental precondition for being able to understand this process. Do we know what he thought? Do we know what he had come to think about fossilized remains and how to explain them? Or was he going on this voyage? It's a phrase that doesn't really mean anything because no one has one of these, with an open mind.
It's a good question. We don't have great documentation of his views as a very young man. And I think he was, he's a pretty standard, smart, upper middle class teenager who he was due to be a clergyman, as was the expectation for men of his class at the time. And he is not enamored by medical school, and it's an opportunity to go off on I mock it as being an extended gap year, which it really is, but probably the most consequential gap 5 years that any 22-year-old has ever taken. I think there's another aspect which is worth us thinking about, which is that the idea of Victorian collectors being this great sort of hobby developed during the Victorian period, which forms the foundation of so much of the science that developed in the 20th century and that we now rely on. It comes much later. The fashion really it's not started by Darwin by any means, but his obsessive collecting and documenting and note-taking is part of this is the upward curve of Victorian collecting as a hobby. In the couple of centuries before that, we've talked about Linnaeus on earlier programs in Past, Present, Future. And Linnaeus's contribution is part of the setting up of the classification system, which involves collecting things from around the world. And I think that's another really significant part of the development of evolutionary theory, is for it to become global. So the Linnaean classification people, Linnaeus himself, didn't really travel extensively. They have access to their local environments, and increasingly they have access to animals and plants being sent from the expanding colonies back to wherever they were, mostly in Paris or Uppsala or London. Darwin's, I guess, one of his luckiest breaks is that he chooses to actually go, and with that mindset of the great collector, begins to see things that he recognizes are difficult to explain according to the current models. You've got people like Buffon and then subsequently Georges Cuvier, also part of the Jardin du Roi, although I suppose it's changed its names after the First Revolution. Buffon develops this idea of degeneration, which is that the variety that you see in different species comes from, again, this sort of Platonic version, which is that there is a version which has the essentialist qualities of whatever species you're looking at, and that varieties degenerate towards that type. And I think that sort of essentialism is really difficult for everyone to shake until The Origin of Species. I'm jumping ahead because I think the consequences of essentialist thinking are really profound, and that's where a lot of the revolutionary pivot actually happens. But that's 20 years after the Beagle.
It is interesting what you say that, say, for Linnaeus, people are sending stuff back, and almost by definition, people will send back what they think the person who's receiving it wants to get. That's sort of how the world tends to work. In Darwin's case, he goes himself, goes to this strange place, Galapagos Islands. Is there a sense that he was looking for something, or was he just going in a spirit of curiosity and collecting and noting and tabulating and all the rest, and something happened out there that just made him think, this has to be explained, and we cannot explain it in the terms that we're used to? Was it genuinely, for want of a better word, a discovery that he couldn't have anticipated, that he was even looking for this evidence before he went?
Yes, I think it is. It's not a discovery in the sense of he saw something that he'd never seen before, but it's an emerging discovery, which is that there are things about the natural world, both geological and animals and plants as well, that don't make sense under the current models in 1831 or whatever. And those include things like, well, why, if everything is created for its own environment, if you see similar environments in different parts of the world, then why don't you just get the same animals there? You know, why are there ostriches in Africa, but in very similar environments in South America, they have rheas, which are similar characteristics, but clearly different species according to the taxonomy, which is correct. We now know their shared ancestry is millions of years before that. Galapagos was significant in the voyage of the Beagle, but it was the world trip which was the overall significance. He doesn't spend any time in Africa, apart stops off at the Cape, but doesn't see any great apes, but sees many, many monkeys en route, and particularly in South America. And that's not irrelevant because he only meets his first great ape in London Zoo after he's come back from the Beagle. And so that's where humans enter his grand narrative, which we'll come on to. The Galapagos is significant for a number of reasons, but one of them is the relationship between the geology and the history of life on Earth, which is that he recognizes that these archipelagos are new, right? They're formed through volcanic eruptions, and that means they have a peculiarity to them, which includes that islands become sequentially formed. And secondly, that you get strange things like, to do with the shape of volcanic eruptions under the sea, you get lakes forming in the middle. And that creates different environments which are unusual compared to most land on Earth.
When you say new, did he have any sense of how old new still was?
That's a good question, and I don't know the answer in relation to the Galapagos, but by the time we get into the 1850s and he's spending a lot of time with Charles Lyell and thinking about the age of the Earth and how old geology is. I'm in southeast London, about 10 miles from Down House, which is where he did all of his work. And the Weald, which is this huge chalk formation that is the top of the South Downs, which runs from the South Downs under the Channel and into France, Darwin estimated that it had to be 300 million years old. The formation of this rock, this chalky rock, which is the South Downs that he would walk on every day, had to be hundreds of millions of years old rather than tens of thousands of years old. And that became enormously controversial. And many of the geologists, sensible scientific geologists of the time, said this cannot be the case. And the age gradually creeps up. And the crazy thing is, he's absolutely right. Those sorts of numbers are much closer than the tens of thousands of years as described previously, but still many orders of magnitude out from the actual age of the Earth, which is just incomprehensible. But on the Galapagos, he sees newer rock formations, newer islands.
But old enough to allow for the time frame he's going to need.
Exactly. And the classic example that we teach to kids, my daughter's 11 and they're doing this in school right this week, is the finches. Right? So these birds, which are clearly the same species, but they have very different beaks. And they have different beaks that he observed were adapted, were appropriate for the environments, the different, subtly different environments of those islands, whether they were wetter or drier, or whether the food that was available on them was hard or soft or nutty or whatever. It's a good bit of the story of Darwinism, and it is significant in terms of his developing these ideas, but it is a small piece in the grander narrative. But it's that these birds live on specific islands and they are adapted to that environment, very specifically to that environment, but they're clearly of the same species. So the conclusion he begins to come to, and this is the pathway he sets himself on, is shared ancestry. There is variety in these species, which is best explained by shared ancestry, which means that puts us on the pathway to evolution.
I realize these questions are almost impossible to answer, but it is one of the puzzles about any great discovery or even revelation. It was a gradual process by which he came to understand that a very new kind of theory was going to be needed to explain this. In the journey, in the voyage, in his own story, is there a before and after moment? Is it possible to say the point beyond which there was really no going back to the previous explanations? I know it's gradual, and we're going to have to then talk about how long it took for this to get published. But do we have even an inkling of when it might have been possible for Darwin to say, were we to go back and ask him, yes, I'd passed the point of no return?
I don't think there is a specific moment. You see these sort of nodes on his trajectory from the Beagle, which is 31 to 36. And then he's in Gower Street and doing work with Robert Grant, with a lot of comparative anatomy there. And then they move out to Down House, I think in 1837 or 8, after having married his cousin, Emma Wedgwood. And then, as you rightly point out, it's 21 years before the theory of natural selection is announced. And then that's 1858, and 1859 is the publication of The Origin of Species. There are moments in that which I think are nodes, which I think are important. One that I love is in 37, he sketches out the first evolutionary tree in his notebook. And it's this beautiful picture. In it, you can see the radiation of species. There's a center, and there's branches coming off, and those branches bifurcate and turn into 2, and then subsequently into 4. And it's sort of circular. And we talk about the radiation of species, which whenever I say it, I always think that isn't really a word that people use outside of evolutionary biology, but it's the spread. It is how organisms radiate into the many species that we see today. And when we do family trees, big evolutionary family trees, which I have criticized on your programs in the past, they have a radiation to them. They radiate from a central origin. So there's one way, the first most important data visualization of his idea. There's other bits where I think it's 1844, he writes to his friend Joseph Hooker, and he's beginning to explain the idea. And he says, rather melodramatically, he's quite a calm man, but prone to a little bit of personal histrionics on occasion. He says it's like discovering a murder. And I think there's a tone to that, which is two mates, having a laugh in their endless correspondence. But I think he's beginning to recognize that this is going to be a big deal. One of the things that people who don't obsess about Darwin often don't realize is that he publishes 14 books before The Origin of Species. Right? This is not I've been working on this solidly for 20 years, and here it is. Here's the big idea. I've been working on this solidly for 20 years, and in the meantime, I've published dozens of small incremental papers. And I mean, I'm preempting the question about why it took so long. One of the reasons it took so long is because he was meticulous, and his correspondence is phenomenal. I mean, voluminous, because he was checking everything. He was making observations in his garden and from samples that people were sending him, and from the collections he took from the Beagle and from his notes from the Beagle, and talking to pigeon fanciers and animal breeders. And he would write to the experts, and he defers to the experts throughout The Origin of Species in a way which makes it harder to read. I mean, I think it's a beautiful piece of prose, but in that very Victorian way, it does often make reference to people who you think if I had limitless time as a scholar, I'd just find out who that person was, but one doesn't. So it was it was a drawn-out process, not because I don't think he was reluctant to publish. I just think he was cautious.
And the idea itself, which is natural selection, do those two words in themselves signal what was radically different about this than anything that had gone before? So there had been adaptive theories, there had been evolutionary theories, there was understanding of some of the range of evidence that he was going to draw on. But the mechanism was what was missing. The mechanism is natural selection. And it's such a familiar phrase, pair of words. It might be helpful, probably be helpful for me, just to sum up why that description of the mechanism is such a departure.
Well, because it doesn't require any agency. It is an emergent property of variation. So there are various sort of key words in understanding evolutionary theory, many of which have emerged before Darwin, but we sort of really focus on them now. And adaptation is one of them. Descent with modification is a Darwinian phrase that is really useful. But variation is the absolute key. And, his own description, right at the beginning of The Origin of Species sums it up quite nicely, in which he says, there is variation within one type of organism, and it is that variation is the pivot on which selection can act, because some will be within that variation in specific traits or behaviors, some will be better suited to the local environments than others. And they will be the ones that perpetuate through time by having more children and enduring. That's the crux of it. That's the central idea. So the implications of that are that it doesn't require any design. It doesn't require any agency. It is an emergent property of the way nature actually is. Now, we haven't mentioned Lamarck, although we did in earlier conversations we've had. And Lamarck is an evolutionary biologist in the sense that he describes as an adaptive process. But it is that the adaptations occur during the lives of organisms rather than what Darwin proposes and what we now understand to be correct, which is that there is no acquisition of traits. It is the natural variation in the species across individuals that allows the selective process to take place. So we've said this before, evolution is already in the air. Many people have moved away from an overarching intelligent design idea, but there isn't a mechanism. Natural selection is what becomes the dominant idea. He does describe the mechanism of natural selection as opposed to artificial selection, which is what pigeon fanciers have been doing for tens of thousands of years. But he doesn't have a mechanism for what is actually occurring within the organisms. It's just that variation exists. So there's still a long way to go after this. But I do think it is the most fundamental revolution in the history of science for that reason.
The word natural is really interesting in this context because, as you say, I think it is there in order to emphasize that this thing that we can do artificially can happen without us. So it can happen in nature. It's natural rather than artificial. But because it's called natural selection, people are going to go on subsequently to think that there is some kind of process behind it in the way that people often want to think that what is natural is not arbitrary. There are three words, it seems to me here: natural, artificial, and arbitrary. And it's in contrast to artificial. But actually, the radicalism might have been better articulated if it had been called arbitrary. Because isn't that the whole point? And isn't that the thing actually that too many people ended up misunderstanding? That this is all random. Because natural and arbitrary or natural and random, people sometimes think those are different things.
I think you're exactly right. And Darwin himself, who was a fretter, he often had moans about his health and about his family and about his friends. He does say people have really misinterpreted this immediately in the reviews, and people have immediately politicized it. And the very famous debate with Soapy Sam Wilberforce, which we might talk about, he says maybe I shouldn't have called it natural selection because of the implications that come with that. He recognizes as well that there isn't a direction to evolution. There isn't the assumption of progress. There isn't the assumption of increasing sophistication. He recognizes that many barnacle species, he was obsessed with barnacles and ended up really hating them because so much of his work was dependent on anatomizing barnacles. But he observes that there are barnacles that appear over evolutionary time to become less sophisticated or less complex. The way we think about evolution or the way we talk about evolution, it has this sort of natural progress to it towards sophistication. And that isn't the case. It is simply that organisms are adapted for the environment which they currently exist within. And so that is the natural process, which doesn't require increasing complexity. And I have always thought that this feels very unintuitive. Huxley, his great defender, said, "How stupid of me not to have thought of this first." Just because he was such a champion of the idea that he was proclaiming that, how foolish we've been for not seeing nature for what it really is, which is naturally selected and evolved according to this Darwinian mechanism. But I don't think it is that at all. I don't think it's obvious that natural selection should be an emergent property from life. And I think time, we touched on this earlier, I think time is the biggest barrier to that because we simply do not see the process. We see variety in organisms. Breeders, farmers, agriculturalists see variety and select those characteristics for enhancement for our benefits, to make clothes or to eat foods. But I don't think that change over generational time is obvious enough for natural selection, as described first by Darwin, to be, well, it's intuitively correct. Geological time and generational time are hard concepts, and human history is 6,000 years, if we define it by what's been written down. The age of the Earth is 4.5 billion years, and life has existed for probably 3.9 billion years. So we're not 50% out, so we're not out by a couple of orders of magnitude. Conceptions of the emergence and radiation of life on Earth, which were centered on a young Earth and then formalized into sort of young Earth biblical creationism of being 4,000 or 6,000 years old, these are out by 6 orders of magnitude. They're like 1,000,000 times wrong. And I think that is completely incomprehensible to us. They say, you can imagine 50 years because that's how old we are, or you can imagine things, you talk often about things that are 100 or 1,000 years old because we have documented history of this, but we're talking about things which are 1,000,000 times longer than the entire history of our species. And I don't think that's obvious, and I don't think it's easy for us to compute that that's how long it takes for evolution to transpire.
And that's why the comparison with artificial selection is so unhelpful, because artificial selection, you can do it quickly. And if the implication is this is nature doing what human beings do by means of artificial selection, but just randomly, it's nothing like, because for it to happen randomly, arbitrarily, it has to be over a time frame, which means, as you say, it's unimaginably different from what an agriculturalist or a horticulturalist might do, to give it enough time to have those effects without a watchmaker, a clockmaker, a designer, a giant farmer in the sky. You have to completely change your view of the whole process, don't you? You have to be able to see it on a scale which just dwarfs everything.
Yes, it dwarfs everything in an incomprehensible way. And I think that I've always been semi-reluctant to talk about religion in the context of Darwin, mostly because, 10, 15 years ago, when we were gearing up for the 150th anniversary of the origin of species and the 200th anniversary of his birth, that was 2009, the tenor of the public discourse was evolution versus creationism. And many people of my age and vintage sort of got their first breaks in talking about this in the public discourse at this time. And I think it's had a detrimental effect on understanding what actually happened in terms of the relationship between science and biology, more specifically, and religion, which occurs over the 19th century, really. Because there's a huge plurality of views in terms of what type of creationism or what type of essentialist or craftsman thinking there is to explain life on Earth. The young Earth creationist biblical literalists is a later, and it's uninteresting because it's entirely unsophisticated, and it's not on a spectrum where at one end you've got biblical creationism and evolutionary theory on the other end. They're just different things. As an evolutionary biologist, it's not worth having that argument. But you've got a lot of people in the 17th, 18th, 19th century who have much more sophisticated views, which are still fully entrenched in a divine creator, but have very different flavors to them. Darwin, we know, was a fan of William Paley, who is the sort of archetype behind the watchmaker analogy, which subsequently is deconstructed with the blind watchmaker as an idea, that if you find something as sophisticated as a pocket watch in a garden, intuitively it must have had a designer because something that complex could not emerge naturally. Evolution is the blind watchmaker because it doesn't have foresight to design a watch. It's just that all of those pieces over this incomprehensible time period emerge through this very, very inefficient process where bits work until, and if they don't, they get deselected, and if they do, they get retained. Darwin himself talks about the eye as a model for the complexities of evolution, the difficulties in evolution, because the argument goes, and creationists still make this as a pretty dumb argument, which is that an eye only works if all of the pieces work together. It's a very complex organ. It's got a lens, it's got a cornea, it's got an iris, it's got a retina, and blah, blah, blah. You take one of those things away and you're blind. Darwin points this out as a potential problem with this theory, and then goes on to point out that he can imagine that there are organisms through time or alive today that have fewer than the full complement of an eye, but still can see or still have some level of visual perception. So the argument is, well, having some visual perception is better than having none at all. And indeed, now we know that every possible stage of eye evolution exists in living, extant organisms. So again, that timescale becomes the sort of barrier to the argument from incredulity. How could this thing so beautiful and so complex exist? I'm incredulous that it was not designed. And the answer always is, well, give it time.
Who or what did he think was dead when he said it's like coming across a murder? So not God, I think, at that point, or maybe even later. This is not yet the death of God. But when he started to glimpse some of the implications of the theory that he had really stumbled across, but then realized there was no escape from, who did he think had been killed?
Well, I think he was anticipating, as a very polite Victorian gentleman, I think he was anticipating pissing a lot of people off.
Including his mentors, presumably.
Oh, absolutely. And family members. And a lot is made of Emma's religiosity. She was a fairly serious Christian, but I think that doesn't hold up in the history. She was very open-minded and retained her Christianity throughout her life without in any way restricting the progress of his ideas. But it's the great men of science of this era. Richard Owen, effectively the founder of the Natural History Museum and a hugely influential biologist stroke geologist. They were at loggerheads forever, and Richard Owen remains effectively a creationist. Charles Lyell, the geologist, he was very close to and influenced by, but also recognised that they differed in some of their metrics. I am a big fan, I think it's fair to say, and Darwin is not without his many faults. But I think he's a good model for how science should progress because of his collegiate nature, because of his deference to expertise, and because of his caution. He does take a long time to develop the idea. And I don't think it is to do with reluctance to face the consequences of what he described as his one big argument. I think it's mostly because he was being cautious, careful, deferential, doing the research. His hand is effectively forced in the mid-1850s when he receives letters from Alfred Russel Wallace, who has effectively come up with the same idea whilst travelling around Southeast Asia. But it's not confrontational. It's all very positive. A lot has been made of them being in competition, which is just a nonsense. The idea was first presented, natural selection was presented on behalf of both Darwin and Wallace. Darwin was ill, because he was often ill. And I think that's not insignificant in taking 20 years to get to publication. He was bedbound for days and weeks on end, having been bitten by a bug on the beagle. We don't really know what disease he had.
Like so many Victorians, he simultaneously seems to have been ill all the time and incredibly productive. That's one of the great mysteries. They were always taken to their beds, and yet books would emerge on a sort of 6-monthly basis.
That's true. And if you go to Down House, which I thoroughly recommend because it's been preserved really brilliantly, you can go into his study, which has been reconstructed as it was. And there's a curtain behind which there is a vomit bucket because he would get up from his desk and puke all the time. He had a very strict plan for the day, which didn't seem to change that much when he was in Down, which included, time to read. He'd go for a daily walk on what's known as the Sand Walk, which is a path around Down House where he'd do some good thinking and look over the South Downs. He'd do his correspondence. He'd have a kip in the afternoon, and then in the evening, Emma would read a novel out loud to him. So that's just a dream life. I've thought about proposing to my wife that I lie on the sofa while she reads novels to me, and that would help my thinking, but she hasn't gone for that. And then travelled around a lot. So, spent a lot of time outside of London talking to collectors. Not just talking to collectors, he also spent a lot of time treating his ill health. So he went to Malvern in order to receive the waters. I want to tell you this because it's not well enough known. It's definitely a cul-de-sac, but I think it's a beautiful piece of trivia here. Darwin's last piece of written work was published in Nature, and it was a letter about barnacles to an expert in Northampton, and the expert's name was Walter Drawbridge Crick, and that was Francis Crick's grandfather. So Darwin's last contribution in scientific literature was to the grandfather of someone whose theories in the mid-20th century would go on to prove beyond all doubt that Darwin was absolutely right. It's not really relevant to the story, or maybe it says something about the closed circles of who does research in science over the course of the 19th and 20th century, but I just like the circular nature of that relationship.
When the theory was announced in 1858 and then the book was published in 1859, there is a version of history, which is that very quickly people could see that quite a lot was now dead. Like there had been a murder across the land, as it were. Vicars picked up this book, read it, and took to their beds, and some of them didn't get up again. It just exploded on the landscape, which I'm guessing isn't true. I mean, it was shocking to some people, and it was deeply controversial from the off. Within the communities where it was first announced, how much recognition was there? Not from the people who were just going to resist it, but from the people who were open to it, that something truly seismic had happened.
I think there was an instant recognition that it was major. And then I think there's a lot of over-interpretation or sort of politicized interpretation of the significance of the work that happens without Darwin making a lot of comment. So he pushes the idea out there and then retreats back to his sickbed. And, we have a lot of correspondence from this time, but he's not out there on platforms. He doesn't even present the idea in 1858. That's Hooker and Lyell. But you get big criticism from Richard Owen. You get big criticism from other geologists who say the age of the Earth required is not long enough. You get a lot of support from some religious organizations and shock and awe from others.
So, but just to be clear, the criticism is the age of the Earth is not long enough, therefore the theory can't be right, rather than for this theory to work, we need to expand our ideas of how old the Earth is. So maybe we're wrong about how old the Earth is.
Yes, I think you get some intransigence from the geologists because they say the evidence doesn't support the age of the Earth being as old as what is required for your theory. Right, so focusing on the geological argument. Another thing worth mentioning is that there is no mention of human evolution in The Origin of Species. There's a brilliant line. He says, in future, light will be cast on the story of humans, or something like that. He holds back from saying in the publication, in The Origin, that humans are also part of this evolutionary tree. He has corresponded with many other people and written about it in papers in the years coming up to 1858, 1859, but pulls back from saying that humans are going to be in here. And in fact, we have got really specific evidence of that from his correspondence with Asa Gray, who's an American naturalist who was a big Darwin supporter and provided a lot of information for Darwin for developing his ideas, that he actually says, I'm deleting the section which says, and humans are part of this. And then it's another 10, 12 years before he applies natural selection to humans.
But do even the early critics spot that his reluctance here is a potential point of weakness? Either he's going to have to commit to humans being part of this story too, in which case they can throw up their arms and say we're not apes, or if humans are the exception, then this no longer is a all-encompassing theory.
This is the key point, and this is why I think it's the most revolutionary idea of all, because he holds back from saying that through personal reluctance and not being a firebrand on stage. Some clerics respond by saying this is fine because they take a much more non-interventionist view of God, a sort of deism. There's a book published by a bunch of clergymen a couple of years after in which they say that God is a lawmaker. So he sets up the rules of the universe. And they're opposed to miracles because miracles contravene the rules of the universe as set up by God. And therefore, miracles is an atheistic viewpoint. They take this view that this natural process is the clockwork universe as decreed by a non-interventionist God working. I think a lot of this part of the conversation is characterized by the famous debate between Sam Wilberforce and Hooker in Oxford, in which women fainted, and this very pithy line about that Soapy Sam said, are you descended from an ape on your mother's or your father's side? And there isn't a transcript of what actually happened. I think a lot of this has been mythologized, and it is good drama. Hooker's response was, his actual response is really long as transcribed, and it's so unpithy that I'm going to paraphrase it. He said, I'd rather be descended from an ape than to use my great intellect to support such obviously untrue things. In mid-Victorian public debates, that's a real zinger. No one has ever managed to persuade me that half of what happened in that debate actually happened. They're good stories, but I think that the reaction was much more nuanced and much more generally supportive of his grandeur, the grandeur of his idea, but the meticulousness of his work. It's very difficult to argue against it. There are many things wrong in The Origin of Species, but if you read nothing else, read the first page and the last page, and if you can come up with any criticism on that, you're a better biologist than I am.
To what extent, when it came out, for the people who could see the merits of the theory, and some of whom were blown away by them, was there still a lingering anxiety or doubt along the lines that if we can't describe the internal mechanism, if we can't describe how the variation happens, and what we are left with is this brilliant description of the process itself, which makes sense of the process, but we can't know what's going on the inside and lies behind it, that the theory in the end is incomplete? Was there a feeling that this was the incomplete version because that underlying explanation hadn't been arrived at? Or could people see that even in the absence of that, this was the thing that made sense of the world in a way that nothing could compete with?
Well, this, for me, is where the story gets interesting because, and I suppose this is how it fits into your revolutionary paradigm, which is they're the culmination of things, but they're the starts of things. Because what happens next is 150 years of testing and the development of the discoveries of the mechanisms and all the stuff that Darwin gets wrong. And the next 50 years, 40 years really, they don't have a mechanism, and many ideas are tested and described. And from the scientific milieu, when people are testing natural selection as an idea, you get the emergence of evolutionary theory as we currently understand it, and why there are thousands, if not millions, of evolutionary biologists and geneticists who are very, very busy still developing the ideas of evolutionary theory today. Unpredicted things, which I'm sure we will talk about, such as how the mechanism was discovered, how genetics fits into it, how the ideas that have emerged from separate branches of the natural sciences fuse with this big idea. So I've been ungenerous with the idea of scientific revolutions in the past, and I think I pretty much agree with Simon Schaffer and your episode about the scientific revolution saying much more about us today than it does about supposedly when it happened. I would even go harder and say I'm not sure there was ever such a thing as the scientific revolution. I do think, with all the build-up and all the consequences, I do think things were different. Well, not the day after, mid-July 1858, but there is a pivotal point where the nature of our understanding of life on Earth, and by extension in the universe, and by extension including humans, is fundamentally different in 1859 than it was 2 years before.
Part 2 of my conversation with Adam Rutherford will be available tomorrow as a bonus episode on PPF+. So if you would like to get it, all you have to do is click on the link in the show description or go to our website, ppfideas.com, where you can see how to subscribe. There is a year's worth of bonus episodes available for you now, as soon as you do subscribe, but you will also get Adam Rutherford explaining how Charles Darwin's ideas evolved after the publication of On the Origin of Species, and also how Darwinian understanding of evolution changed human understanding of our world. That'll be available tomorrow. Next time in our regular slot, we're taking a very short break from Revolutionary Ideas and we're going back to something that we were doing earlier on. I'm going to be talking to Helen Lewis about a film, Network, but this is a special episode because it was recorded live at the historic and gorgeous Regent Street Cinema in London. Following a screening of the film, Helen and I went on stage in the cinema to discuss what we and the audience had just watched. So that's next time, Helen Lewis talking about one of the great political films from 1976. If you don't know it, it's the one in which a newsreader says, "I'm mad as hell and I'm not going to take it anymore." Next time, Network. This has been Past, Present, Future, part of the Airwave Podcast Network.